Thanks everybody for being here for this presentation. It's always a privilege. This time I just wanted to focus on a couple of things. What I want to talk about is how do I, as a performance engineer, and with this experience that Henrik was talking about, being a golden oldie, how have I tried to protect myself to build performance tests that are bulletproof, or that I can find the problems early and raise a red flag early, and things don't slip through my testing and make it into production and they don't see problems? And how have I protected myself from that? What are the things that I've learned? So some of this that I'm going to be telling you is 101 stuff, and I think a lot of people still need to go back to the basics and learn this. We talked about the last session about how sometimes you need to go back to the very basics and start again, because some people don't learn the fundamentals. But I'm hopefully going to explain at least how I do it, but not dogmatically to say you have to do it this way. I'm just hoping you can gain something from how to create the perfect performance test scenarios to catch problems early, what you need to do during that, and what I found to be important to me to find those issues. And I call a performance test scenario a symphony of destruction, because that's exactly what I'm trying to do, is kill your application. And it's an orchestrated event, and I love doing it. And for those of you who are Megadeth fans, you will get the reference. So we're going to talk about that, and then I'm going to just share a few stories. Don't worry, we will look at a couple of graphs here, but I'm going to be sharing something really cool with you. So before I do that, I want to show you a picture of my studio in Nashville that I had for several years, up until just a couple of years ago. This is just the guitar speaker cabinets that I had to mic guitars and record those. So those of you who aren't guitarists, or you're not a musician, or you don't know anything about recording, you're probably looking at this and going, okay, why do you need all these speakers just to make a guitar sound? Don't you just need one and you just play through it? Well, my mentor in music always taught me anything worth doing is worth overdoing. And what most people don't realize is that the speaker makes up to 40% of the guitar sound. And just like with an application, you have all of these pieces, the network, the front end, the back end, and all these choices that you make about which databases you choose. You could think of these speakers kind of like maybe the front end or the JavaScript library that you choose, like React or something else to build in, that would take up a percentage of the performance of your app. That's exactly the way this is. And if you want to record certain types of guitar tones, you use certain types of speakers, and everything in that chain counts. So as we start talking about this, think of the little things that you can do to make your performance engineering, your performance testing more bulletproof. I'll use another analogy here about little things, because when you've been doing this as long as I have, performance testing just becomes natural. You have a process, you do it, it works. But somebody who's been doing it less than, say, 6 months, and they're still trying to figure all this out, and it's such a wide scope of things that you have to learn to be an engineer, they get overwhelmed with it. Bruce Lee was probably arguably one of the best martial artists that ever lived, and he made an art out of it and made it look so easy for him to do these complex moves. And people always asked him, like, what was your secret? Like, how do you do what you do and make it look so effortless? And he said, when I didn't know anything, I thought a punch was just a punch and a kick was just a kick. And then when I actually started learning the art, I had to break it down and learn that there are all kinds of different ways that you can punch. And I had to practice each one and master each one. So every punch was different and every type of kick was different. But after I mastered it, a kick was just a kick and a punch was just a punch, because then it becomes just part of you. It becomes natural. And I feel like, as for those of you who are just kind of up and coming, and you're learning this, and you maybe do feel overwhelmed, you'll get there, I promise. But it's by repetition and doing it and making it part of you and part of a process. And then you'll then understand why you need 20 speakers to get one guitar tone. I am going to be using Neotys in this presentation, and I got to say, I'm going to give Neotys some props here, because they're the only load testing tool that has an appearance setting called metal. And I'm totally convinced if Randy Rhodes were not a guitarist and were still alive and were a performance engineer, this is the setting that he would choose. And all of you rockers, if you're not choosing it and you're using Neotys, you're just wrong. Okay, you're just wrong. So that's my little plug for that setting. So you should be using that. So I'm not going to get totally like in depth in all these different graphics and all these sides. I want to explain this stuff to you, and I want you to maybe this is a part where you take notes, right? Or you just watch the video over and over. But I want to talk about the types of these orchestrated performance test scenarios that I create when I come into any project. This is typically what I will do. I will create once I've done my scripts, obviously I've talked to the company about what they're trying to achieve, their major objective, what are those business processes or user stories that they're wanting to automate. We've got all that kind of out on the table. And now we're actually trying to create that load test and the types of load test scenarios. And the first thing I'm going to do is take each one of those user stories. Typically that's 5 to 10, usually 5 to 6 business processes. Each one of those are somewhere around 5 to 15 steps max. And they've all got timings around them, and they represent, if it's a web app, web pages, and page requests. I will baseline each individual one of those for a period of time. It could be as little as 15 minutes or up to an hour. And I pace them out with a little bit of iteration pacing, like maybe a second or two in between, but I will run them over and over again. Yes, there may be caching. I want to see how the system reacts to this single user test. Is the CDN working properly? Are we even using a CDN? Are there certain APIs that are taking a lot longer than others, just disproportionately? I'm going to be monitoring infrastructure and specific metrics while I'm doing this, so I'm going to know if the database is taking a lot longer for certain timings than others. And the most important thing is, if I've set a service level objective like 5 seconds or less for any rendered web page or any transaction, if I'm already breaching that at this point with a single user, hold it a second. How come, number one, are we not meeting an SLA with a single user? Because if it won't work well with one, why should we go forward? So we don't have to go through 3 more weeks of testing to find out something sucks. Let's find it now. The second question is, how come a developer isn't opening up a browser and opening up DevTools and looking through this business process and just seeing, are we meeting that? You can look at those network timings and see if you're breaching it. It's taking 10 seconds to do a search and you're expecting 5. We should stop right now and not do load testing. Let's do more engineering and tweak and tune the issue. So right there, you start finding and fixing the problem as early as possible. That's my method for doing it. But now, let's say you get past that and everything looks good because everything's great under single user load, right? The next thing I will do is a top time test. Now that lingo may not resonate with some of you, but the old timers will remember that's a load runner 101 type of thought process. If let's say your total goal is 1,000 concurrent users doing this mix of transactions, I don't just go after the baseline of a single user and then try to ramp up to 1,000 concurrent users. I mean, how do you know that the business has even set up the environment to handle 1,000 users? How do you know that? Well, you're going to ramp up, obviously, but I'll ramp up to about 20% of that level. You can choose whatever ones you want. I don't like to stair step it with doing, 10 users, 50 users, 100 users. I'll choose about 20%. So in this case, if it's 1,000 concurrent users for a full load, or our total, what I call a benchmark, I'll ramp up to about 200 users. And the profile for this type of scenario would be about a 20 to 30 minute, very slow ramp up to see how the system is reacting. I've got my monitors all running, my smart monitoring. I'm not monitoring everything. I'm monitoring the things that should be monitoring. Talk about that in a minute. And it's usually about a 60-minute window with a very quick ramp down. So from that, I'm going to first find out, am I seeing patterns where there are certain transaction timings that are rising above the others in a disproportionate way? Or is the database crumbling under certain transactions, like a search where an index might have been missed? And I'm going to find it well before I attempt to totally kill the system. And that's why we call it a top time transaction test. You're looking for top timers and then determining, well, now if we're breaching our SLO, at least it's more than a single user. But again, if we see that, we stop, we raise the red flag, we notify everybody, the team jumps on it and figures out, what's the issue. And maybe we hold it at that level until we're ready to move on. Maybe we found that we have bitten off way too much and we're definitely not ready for that full load. But let's say we meet that. Then the next stage would be doing what I call a benchmark. And this would be whatever I'm expecting to be a full load concurrency-wise in my production system, and it is a true load test. And you probably heard this definition in other presentations before, but a load test being What is your real world conditions? What is that perfect storm that you might have? What is your Black Friday hour? Basically, we're looking for this peak hour, because if we can meet that 1 hour that's the worst, we can meet the other 23 hours of the day, hopefully. But it is a realistic type of thing versus just trying to kill the system with unrealistic load. And that's an art to create that, and we will talk about how I get there to that in the next slide. But that's the same profile, about a 20 to 30 minute ramp up. Obviously, if there's more users, it may take longer to ramp up if it's a 5,000 user test or what have you. But I'm watching that ramp up. I'm slowing it enough to see, giving the system enough time to react, and watching those performance monitor metrics, those infrastructure metrics, those database metrics, application specific metrics. And then I'm, basically taking inventory while I'm going. If we meet that, and that's a big if, then I'm going to cut off the ramp up time. I'm going to cut off the ramp down time. And then the timings I'm going to use will not be average. They'll probably be the 90th percentile number, but a window of time where we only include full load, not the ramp up where those numbers would be skewed, because they're obviously going to be a lot better. That's my most conservative number that I can come up with. And if you're still meeting your SLOs at that point, great, wonderful, everybody's happy. The performance engineer in me is a little bit more relieved. Still not fully, but nothing it ever makes me feel really good as a performance engineer. Everything sucks until you just exhausted every resource you can to prove that it doesn't. So let's say we do reach that. Well, we wouldn't stop there. We also want to do something called a scalability test. And this is really up to the business to decide, like maybe how much they're going to grow over the next 6 to 12 months. Why stop with 1,000 users? Do anywhere from 20 to 100% more than that. So 1,200 users, 2,000 users. If you're out of license budget money, then possibly you make those users run a little bit faster with a little less think time. You do a little math. I wouldn't do more than, say, 2x of the speed. But you can fudge it just a little bit to give it a little more volume there. And then if you just do not have enough licenses, but you need to reach that volume, then you stop doing it as a number of virtual users, and you turn that into more of a transactional based metric. So we're not looking for the number of concurrent users on the system. We're looking for how many transactions can we push through this thing in this period of time. And that's the metric that you then use. But you can't got to use both of them. You kind of have to go from one to another. And usually it's a license limitation. And then I have down here by the way, that's the same profile, monitoring, same time of ramp up and ramp down. Now the ramp up and ramp down really changes in this next one, where I call it volume soak. Some people would call that a duration test, where you could run that full 100% benchmark test, but for a very long period of time, 8 hours to 24 hours or more. You want a very slow ramp up, a very long time where you hold that, and then you have a very slow ramp down. And the purpose here is to try to bring long-standing problems that would only occur over 90-day, 180-day windows, like slow memory leaks that might emerge, and then you don't know why every 3 months or 4 months you're having to restart services or reboot servers, and people are getting called in the middle of the night, that type of thing. That's really what that's for, and that's pretty easy to find with that type of a test, as long as you do the slow ramp down, monitor the memory and some of the other utilizations that you have, just make sure it's given back what it took. And then finally, this last one is a stress test. So a stress test would be finding the first point of failure. And sometimes I won't even run this, because I really consider it optional. Because if you're doing a true load test, if you're really emulating that realistic perfect storm, that's the more valuable information to the business as far as making a decision on, in my opinion. But a stress test can be useful if you want to find out, well, what is the first point that's going to fail? I may be able to tell you that in 10 minutes, just removing the think time and kicking off 1,000 users as fast as we can, no pauses, and your web server's down, right? So if you're not prepared to do something about the information, it may not do you any good. Well, are you ready to stand up a load balancer, put 5 more web servers up there, and maybe now, with the cloud and everything, it's very easy to spin up some more containers if you need to. So that would be a reaction to news about a stress test, to find out where the initial failure is, and then by changing some configuration or something, you move that bottleneck down the line, down the chain, and then deal with it there. Notice that I mentioned one thing that's in common with every single one of these. It is monitoring. I still find that about 50% of the clients I work with still aren't using effective monitoring techniques. And when you miss that, or you assume that, hey, we've got everything over in the cloud, AWS or Azure gives us some default monitoring capabilities, but it may not give you everything that you need. You really need to think through what you're monitoring and how to monitor it so that you don't over monitor and skew the results based on how much information you're gathering and how fast. But you need to be able to see things that aren't just CPU, memory, disk, and network counters. I'm going to show you a graph in just a few minutes that is very specific to Microsoft SQL Server. And if you're not monitoring SQL Server specific metrics, you may miss something. So that is my tried and true methodology that I go through every time. Have I had to alter it sometimes? Yes. But most of the time, this works as a great starting point, especially for you folks that are new. Try this, see if it helps you. The other thing, well, Scott, you always brag that there's never been an application that you've tested that has failed in production because you tested it. And I'm not lying about that. But have there been applications that have had production issues with performance of an application that I tested? Absolutely. But it was always the thing that was out of scope that they told me, don't automate this, don't test this or time this, we're not worried about it. Only a handful of users would ever use this. They're definitely not going to do it at scale, and we don't have time to do it. Or it was a scope issue. We either didn't have enough time and it wasn't included. And it was that one thing that they didn't think would be the problem that ended up biting them. So if you've got the right scope coverage and if you're talking to the right people to set all of this stuff up who understand the business, you're definitely going to be on the right track here. So now you're going to get something free. So how do I create that perfect symphony? I use a spreadsheet. This is the spreadsheet I use, and you can see a link down there at the bottom of the screen. You can either go there now. It's a Google spreadsheet. I'm going to be talking more about this in a future blog on scottmoore.consulting, where I share this link and I go through what I'm about to tell you now in a lot more detail. I just don't have time to go through it all, but it's going to be kind of high level and crude. And I do know this. I'm going to share this with you, and there will be two reactions to it. There will be the first group of people who say, this is great, I'll take it, I'll use it, and wonderful, Scott, we love you. And then there's going to be the other folks, and I've seen half the names on there, and I know half of you. And like good performance engineers that you are, you're going to want to fight with me and debate about every freaking cell in this Excel spreadsheet. Guess what? I need both of you, and I need both types of feedback, because I want to share this with the community and make it better for everybody. So if you see something in here that's just totally wrong or could be done better, or you think it's a waste of, that's fine. Let's talk it through and let's make it something that is useful. So at a high level, everything that's in yellow is something that is typically calculated, and everything that's not is something that you have to put in. Most of the information that I'm putting into these columns on the left-hand side are things that I either get from something like Neoload, or I get it from the business. There are two that I have to discuss with the business first. And I'll just go through them really quick. Starting from the left-hand side, we just have the group number, the number of the script, right? And I have 10 scripts here. I named them, obviously. The number of users column is next. That is something I have to talk to the business about. Well, what's the full load? It's 1,000 concurrent users. Well, let's break that apart. How many users per business process? How are they distributed? What does that look like? And what's the closest to production? And the other column I need from them is how the volume levels that they think they need per user story or per business process. That's the column that says iteration for test period. So the first line would be, so it shows 900 right now. That is another thing. We have to talk through the business. If it's an existing application, you've got production logs. You can gather that information for peak load times. If it's a new application, you may have to just work with VAs and other people really familiar with the business to come up with a good, educated guess. But sometimes you have to do that. Now, these other columns that are over here, I can definitely get from Neoload. So this is where I get the information. So I've created this script called Heavy Metal, right? And I already know, because I put the transaction timings in there in these folders, there are 3 transactions. Under each one of these, they have a mixture of a number of pages, and underneath those pages, they have a number of requests. So I want to find out how many pages and how many requests do I have in this particular script. Very easy to find that out with a check user. So I know I've got transactions here. I know I've got 3 transactions, and I've already played this one time through without any think time whatsoever. And I know I've got 6 pages and I've got 99 requests. So I could come back over to my spreadsheet and fill that information in. 3 transactions, 6 pages, 99 requests. And then the next thing I want to know is, how long does it take to run without any think time? And I've got that information, which is about 3.5 seconds. And again, this is crude. I'm going really fast on this, so just bear with me. There's some other things that I might do a little more detailed, but for the purpose of this demo, this will work. Then I will rerun that with the think times, and I'll rerun that. So I have a deviation built into this. So because of that, I would probably run this multiple times and sort of get some kind of an average of how long it would take. But it's probably going to take somewhere between, I don't know, 15, 20 seconds to run. And when it's done, the totals will be at the very top of this tree. So now I've got 13 seconds. I've had it run as long as 20 seconds. So I'd get some kind of an average number there. So when I come back over to my spreadsheet, and I actually have the spreadsheet here. This is the actual spreadsheet. This column would tell me, all right, how much execution time with no think time, how much with think time on average, and then now I've got all the rest of the stuff out of Neotys. I got all these columns filled out. Now all of these other columns on the right begin to calculate, and I've got some guardrails put in here that will tell you, if you have too many iterations and it takes too long to run, these pacing numbers that you're trying to pace in between to get your volumes correct for an hour long, and it's an hour long test with a 20-minute ramp up, to make sure all this stuff fits in. If these numbers start going into the negatives, it's going to tell you got a problem. You need to look at your numbers and make sure that they add up. It's also going to tell you how everything is distributed by user story, and it automatically makes this graph for you. So I can go back to the business and say, okay, if we take search and logins and all these things, if we break them apart, does this look like a production load? If it doesn't, we need to come back up here and talk about it some more and change some of these values, change some of these numbers, and try to make them match. So is this perfect? No. But I'd love to have everybody's feedback on this to see if this is something that would be very useful for you to just kind of fill in and at least start with this and see if it gets you there faster. And at least to me, it helps keep me in mind as to how hard am I actually hitting this application. And one thing I didn't mention, and I should have, is about those think times. If I go back to my user path here, I've set a override of 2 seconds, 2,000 milliseconds between each one of these pages and for delays, and then I've added a 30% deviation. You can take all that stuff out and manipulate it and replay it back and forth and come up with different times, and that's how I actually create my full load test. Then I'll do extrapolations to get 20% test volumes and lower volumes from there. The final thing I wanted to show you on this spreadsheet is the statistics page. I went and all of this stuff is all calculated as well based on what you put in the first one. I just ran a 20% test and looked in Neoload analysis and just pulled out the number of transactions that ran for that test, the number of pages, and the number of requests. And I can find out, since I do have a deviation in there, how far to the left or the right of my standard timing or my standard did I do. So here, if I didn't put any deviation in, I would have hit 75,000. But I hit 79, which means I'm hitting a little bit harder. Next time I run it, because there's randomization, it might be lower, it might be much higher. But these are, again, kind of guardrails. If you're staying within them, then you can kind of expect, if I run this test over and over again, I have organized chaos, but I'm going to generally end up with about the same level of volumes. And to me, it just helps me think through this and figure out, am I testing this thing the right way? So I've only got a few more minutes left, right? I've got about 6 minutes left, and that's plenty of time to go through the rest of this. So that's your first freebie. Let's keep this between us until after the PAC presentations have been released on the video. Then I'll release a blog, and we'll release it to the rest of the world. And that would give me time to get your feedback included into this spreadsheet. So let's talk about some stuff that I've seen. These are road stories, right? So, and this is something that is kind of recent. I think it's important. I've talked about the importance of designing these scenarios and stopping when you need to tune it, the importance of monitoring, number two. Number three, the importance of service level agreements or service level objectives to be put into your scenarios as part of the results. As you can see, as Kerry King of Slayer is turning up the volume and playing Rain and Blood, there is actual blood raining from the sky. No, that's not what this is about. This is a test where I just continued to ramp up to somewhere around 500 users, and I've got a little bit of scaling in here for that and I had to protect client data here. But as you begin to start seeing this coloration, it just means that service level agreement of 5 seconds for rendered page that I put in is being violated more and more as we go, which we would expect, and we see this. This is just, it becomes terrible. But we started violating that way back here, and it was somewhere around the 100 to 200, about the 200 user mark is when everything really started going south. South of Heaven, which is another Slayer album, by the way. So we started looking at, so this is one thing. This is why it's important to have this, because you let the test results tell the story. And according to the test results, you've breached your SLA, which means you're a failure. It's an easy way to say the baby's ugly without them blaming you, the tester, but they're looking at test results to indicate this problem. So then we move on to another graph where we knew that the database was really utilized heavy here. So we started looking at the database, but we couldn't get database-specific metrics just from AWS CloudWatch. So we actually had to turn on Windows Perfmon with two EC2 machines in the same subnet and pull these metrics. So as I ramped up to the number of users, as I got up to about the 200 mark, this is a 20% test. This is a top time test. I'm not even at the full load yet. Well, we can see that the user connections has reached 100, and it just stays there at 100 once I get there. And once it reaches 100, that is the exact magic configuration number for the ADO.NET setting in SQL Server, that once you hit that configuration wall, all your transaction timings are going to be higher because everybody's in the pool and nobody's getting out. The CPU of the SQL Server goes to 100%. It starts to queue, and over a period of time, this transaction called View Scorecard just is horrible, right? So this is a .NET application that we're looking at. So it's not necessarily a SQL Server issue, but it's that ADO.NET user pool connection, and since it's hard coded. But does that mean that we should go in and just start changing all these numbers? Well, obviously not. This is where we would get development DBAs involved and having them look at this and say, okay, we showed you the first graph where the View Scorecard is definitely breaching the SLA, but here's why, and here's how many users it takes at this load to start seeing that problem. Now, what are we going to do with it? And I had another graph, and yes, I threw in those people. That's not something you get out of Neoload, but I have another graph that just shows these spikes. What we found was in the database, if you were a user who had been around a long time, especially if you were upper management, there was a lot of data that had to be crunched to show your scorecard. But if you were a new user and you didn't have anybody that reported to you and you only saw a little bit of stuff, we had really low timings here. So it depended on who you were and what ID you were, even not under full load, as to how long some of these timings would take. That's a fundamental database architecture issue that needs to be dealt with. That's not just straight, hitting a user. So there's multiple layers of problems here. And had we not looked at all these different things that we're monitoring, we would see there were high times. We would see the thing is not working correctly, but we wouldn't know why. So having these SLAs that let the test tell the story, having the right monitoring turned on, and seeing the smart stuff that you're supposed to, and doing it as a methodical way of increasing that load and taking a look every time and stopping and raising the red flag as soon as possible. Those are the three things that have kept me out of trouble all this time. So that's really what I wanted to share with you in this presentation. And if you got anything out of that, I'd love to hear from you about that. And I think I'm right at the 30-minute mark. But before I end this, I want to tell you that you now, for listening to me this amount of time, you now get your second freebie, which is a free song. So several years ago, I recorded a heavy metal song with a singer named Rob Rock. You should look him up. He is well known in the metal community as one of the best heavy metal vocalist in the world, and he performs with a band called Impellitteri. They've been around for, I don't know, 15, 20 years maybe, several albums, and I was fortunate enough to have him sing on my song, and you're going to get that free. It's available on Apple iTunes, Amazon, and other places, but you get it free. All you got to do is send me an email to help@scottmoore.consulting. I'm going to send you a URL link, and you get the thing free. So that's your second freebie. And this is how you can reach me. If you want to talk about this spreadsheet, if you want to talk about the way I've done things, fight with me about it, this is fine. This is how you reach me. And like Henrik said, feel free to go out there and check out my YouTube channel and look at the kooky stuff that we did on the performance tour last year, 5,500 miles around the United States and multiple cities, talking about performance testing and performance engineering and some of the things that we found out by talking with experts, vendors, et cetera, and we had a lot of fun too. So I was real happy about that.
It was pretty fast, a lot of interesting stuff. For those who wants to learn more on performance, definitely your track is interesting. And hey, here it is. So before we start, I'd like to first cover one of the questions that has been asked by the audience. It's one of our PAC members, Scott Stevens. So the question is, it's a 101 question. How do you define your ramp-up time, Scott?
How do I define the ramp-up time? So it really depends on how many virtual users it is. And for most of the clients that I work with, we're talking about 500 to 1,000 users typically. That's either what they buy in terms of licenses. Again, then you'll have this big bang test every once in a while, like once every 6 months. So there's 50,000 user tests, and they'll rent those licenses, and then they'll do it that way. So obviously, if you've got enough generators, you've got enough bandwidth and all that, if you can ramp them up faster, that's fine. But I want enough time that I can see that reaction time from the system. But if I were doing even like 100 user test, I'm probably still going to do about a 20-minute or 30-minute ramp up. The reason why is because I like to set up templates for analysis. And I'd like to have the same amount of ramp up, the same amount of time to run, and the same amount of ramp down, so I can apply that template to the same analysis and then do comparisons between them. And it's a real easy way for me to do that by keeping the ramp up times the same and seeing the reaction for that. But if I was using, a 500 user or 1,000 user test, it's probably 20 to 30 minutes. If it's a couple of users or 10 users, it's probably 10 minutes, but slower than just, trying to kill the system in 10 minutes.
So there was a question from my end. So you mentioned a lot of various tests, part of your presentation. And today we had Roman from Tristan, who was part of the Jurassic Pack, who talked about concurrency. And he mentioning that we do a lot of load testing, but happens quite often that the concurrency testing is put aside. And sometimes concurrency you could discover a lot of problems because of the way you have designed your app or the way the code is behaving. So what's your thought about that?
Well, I completely agree, and I don't think enough testing is done that way. I can probably tell you on one hand how many times I've ever had a client who was interested in some kind of a rendezvous point or crushing it with a concurrency level because they're just trying to get stuff done. It's like, give us the low-hanging fruit, get this thing. And you try to slow them down and you show them the value add by doing that, but a lot of times you just don't have the time to do it. I think it should be done more, and I have found problems when you've done that. The quickest way to kill a web server is to put a rendezvous point on it and then be able to show how these CPUs are reacting to that. But I just don't get enough time to do it. It needs to be done more.
Dennis, do you have any questions for Scott?
Being a performance engineer myself, I received, comments from a few people, that complain that my blog is too slow. So this is kind of funny, you see. So, yeah, and as I said, right. So I'm pretty, don't even know from where to start. So yeah. So Scott, do you have any advice for me, maybe?
Well, wait till you start looking at your weblogs and finding out those same people are probably running load tests on your website on off hours, just trying to take it down to see if they can brag about taking your site down too. Ask me how I know that, right? So yeah, a while back, I actually took my website, which was a straight WordPress site that I had the plugins to try to optimize it, and I went through all that stuff because it was a great learning experience for me. I transformed it over to a static site and put it up there. There's no server, there's no login, there's nothing. It's static content that's been converted every time I make an update. It's sitting up there on Cloudflare. Everything is on a CDN, and so it's pretty indestructible at that point. You're going to get just a second or two for pages, unless I do something and put some stupid large images or something out there. So that would be my biggest advice if you're going to be a person talking about speed and stuff. Just make it as simple as possible. And the perfect website for a performance engineer is a straight HTML with no images. It just says "Hello World." That's the performance engineer's favorite website because there's nothing to complain about, right?
Yep.
Yeah.
Actually, I have that case covered in my talk. Is that one of the baseline steps that I go through before I get to my final stage? So you nailed it right there. That's our starting point too.
Awesome.
Yep. But then had to make a more realistic stub simulation that actually simulated more like a login page, right? So you have to have both cases. But yeah, that starting one is the key.
And I realized presentation was kind of high level. It didn't get into the weeds that much, but all these other brainiacs are going into the weeds anyway. And most of the time I try to feed people with the fire hose as well. But this time I kind of wanted to lay back a little bit and just kind of leave it open for people to take something like that high level and apply it to themselves and put something out there where we can share, and just make it better.
So Steen, do you have a question?
I do.
So Denise, come on, go ahead.
Sorry, guys. Yeah. So just probably it's a good sort of a good option to confirm to convert it from spreadsheet to something like a tool, right?
Mm-hmm.
Do you have thoughts like that, Scott?
If you know good developers, then let me know.
So, Steen, I saw you raising the hands. You wanted to ask something to Scott?
Yeah, first of all, hello, Scott. Long time no see. It's always on LinkedIn, so good to meet you. It's good. If you want to be a rock star, you need to get the basics right. And I think this talk was about the basics, so it was really well explained. One thing that I think that we need to be careful about is what you said about the licenses. We have seen that a lot. People don't want to spend money, and we only have 100 user licenses. We're going to speed it up, time remove. And I can tell you that we had huge issues with a client in New Zealand where the concurrency really mattered because actually it was a claim management system where all the history of pages was being added into RAM, and it was growing and growing and growing, and it's the total number that actually broke the whole system. So what I want to add there is that sometimes you can do that, but people need to be very, very careful and understand what they are doing to know that the assumptions that they take don't impose a risk to what they are doing.
Exactly right.
And then the monitoring thing. I always think I monitor everything, but I don't look at everything.
Mm-hmm.
It's like you have a problem, and then you go through all those counters, and you don't know most of them because I don't know them. But then you see pattern differences. They correlate with what you see there, and you get a clue of where the problem is. So I'm monitoring as much as possible. Do I look at it? No. I only look at it when I need to. And do I understand everything? No. No one can. And if someone says that they can understand all the counters of even performance monitor, Perfmon, not possible because it's complex. But it's a good point. You're monitoring stuff, and I really like your talk. It was good. Well done.
Yeah, and to add, it's cheaper to collect things once than saying, oh, shish, let's rerun the test because I forgot to add.
Or that the problem sometimes doesn't occur anymore. Typically, performance problems, it's you not always can replicate it. And for the production, you have a problem. What's going on? I have it today. I don't have it tomorrow. I do have it the day after. So it's not always easy to even replicate the problem. But then it does occur. And what's the problem? You don't know. But if you have the monitoring counters, you're a step further.
You know, one thing that I didn't mention that I probably should have, I wanted to do sort of a shameless plug here, in that in this particular test that I was showing the results for, because we knew it was a database heavy issue, it was a database problem, I can only get so far with certain monitors. Like Windows Perfmon obviously would tell me the SQL Server basic stuff, then it would tell me SQL Server metrics, but then how do you get deeper to the profiling stuff? Well, you have to have SQL Profiler, you got to have a DBA, or because I'm not a DBA, and I don't have the time to get that deep on every single kind of database because I'm switching projects all the time. I think you that was talking about Oracle and the $$ tables and all that.
Yeah.
You got to know that today, and then next week you got to know, some other day, MongoDB or something. So I found this tool called DB Marlin that we grabbed and we installed. I had it installed in like 15 minutes, and if the guys are watching it, this is for you. But it's a new tool, just came out in December. I was able to install that, and I didn't need access to the DBA stuff. I didn't need access to SQL Server. I just had them create a user for me. So as I'm running the load test, I'm getting those metrics I can get out of NeoLoad from the monitoring. But then I can go back and look in this tool and dive in and get that profiling information and say, it's this SQL call, it's this plan, execution plan, or whatever that I would have to have SQL Profiler to do. And what I really liked about this was tomorrow, if I go do an Oracle gig or I do a MySQL gig, I can use the same tool and I don't have to switch profilers, and I can still get that. So I love that, and that actually shortened the time. So
what's the name of the tool again?
It's called DB Marlin, and I think I Henrik that, and you'll actually be hearing more from me about that. I was so impressed with it. I made a performance tour episode that's going to be coming out probably in about a week or so. I think you'll enjoy it. It's the sushi edition.